All right, thank you, Zakita, for the wonderful words. And Savannah and Jamari, I met them last year and knew the sky was the limit. Now they're taking over my job here up on stage, so it's only a matter before they're going to be a workforce and doing wonderful things. So moving right along, I'll now introduce our final panel of the day, but I've heard from several of you that my Disney joke landed, so back by popular demand, here is round two. Why is Cinderella so bad at soccer? Because she's always running away from the ball. But wait, she also has a pumpkin as a coach. Don't worry, folks, there'll be plenty more where that came from. All right, our last panel is entitled GeoGPT for Real-Time Geospatial Discovery. The panel will discuss how multimodal integration of diverse AI models can enhance the richness and accuracy of geospatial conversational AI experiences, allow humans and machines to have seamless interactions, and empowering users to intuitively engage with real-time maps, and integrate maps, and receive insights through natural language dialogue. While the panel is coming out, please let me introduce the panelists and the moderator. The esteemed panelists are Melanie Corcoran, U.S. Government Business and Technology Advisor, Impact Observatory; Manil Maskey, Senior Research Scientist, NASA Marshall Space Flight Center and Data Science and Innovation Lead, NASA Chief Science Data Office; Matrice Nix, the Chief Technology Officer of Dante; Ben Tuttle, Chief Technology Officer of EOI Space; and Abe Usher, Co-CEO of Black Cape. Please help me introduce the panel. Hold on. That's the panel. Now, can't forget the most important part, the moderator. Chitra Sivanathan runs a technology-focused consulting firm in Northern Virginia and also provides industry support through AI, data, GEOINT-focused organizations such as GeoSisu and Intelligence Research Institute. She is an industry veteran with over 25 years of supporting the intelligence and defense sector with a breadth of leadership experience ranging from well-known industry players such as SAIC, Raytheon, and small services companies and startups. So please help me welcome Chitra and the panel. Thank you.
Thank you.
All right, thank you. As everyone gets settled. All right. So as we kind of get going and talk about GeoGPT, which I'm sure everybody has been in buzzword lingo for the last year, I wanted to really make sure we focus on, I think just like Peter Hyman was describing in the morning, our GEOINT professionals have to focus on essentially collection and analysis in a space and time continuum, right? So as we think about GPT and large language models, this esteemed panel will help us think about making this all mission relevant. With that, I'm going to just go down the line real quick and ask everybody to do a quick couple-minute intro so that everyone has a clue where you come from and how you've been supporting GeoINT all these years. Melanie?
Thank you, Chitra. Hi, I'm Melanie Corcoran. As previously stated, I am a strategic advisor for Impact Observatory. I've been in the geospatial world, sadly, since 1997. I started when I was 5. And in there, I actually had the pleasure of doing the first NASA land cover classification back in those days. I've been lucky enough to be in the industry and see it evolve, going from tape for Landsat to now these exquisite both commercial and government sensors. And then now in the evolving world of using large language models, new ways to approach geospatial information that will make it easier for the average user so that we won't have to have the same level of education and background, but make geospatial data more accessible. So I'm also a guest scientist for Los Alamos National Lab and have been developing R&D programs in the past for the government. And with that, over to you.
Thank you. My name is Manil Maskey, and I'm a data science lead for the Chief Science Data Office at NASA headquarters, where I do a little bit of programmatic strategy development across NASA's all of science divisions. But more excitingly, I actually work on hands-on things at down in Marshall Space Flight Center, where I actually lead projects related to geospatial foundation models and large language models geared towards scientific research and application. My background is computational science, so I'm really not on the geospatial side, but I have been working with the geospatial scientists for about 23, 24 years, both on the academic side. I spent a little bit of time on industry, and then now in government. But our primary goal has been making the data that we observe, which is about 150 petabytes of geospatial data, making that readily available for scientists and applications users, readily available, and providing the systems and the investment that the government has made in terms of the science missions, making the maximum potential out of it. Thank you.
Hi, Martise Nix, co-founder, CTO of Dante. About 15 years primarily working in the federal space. I've focused mainly on building big data cloud systems for multimodal information and then applying information gain techniques to that to answer questions either down at the warfighter strategic level or warfighter tactical level, and then also for strategic command. A lot of what we're looking at right now is how do we enable users to not understand a ton about geospatial or even know what that word is, be able to ask simple questions and then find content that really supports answering that question. So anyways, over to you, Ben.
Thanks. Ben Tuttle, CTO at EOI Space. I'll go even further back than Melanie. This all started for me because my parents sent me to programming camp when I was 6. I was a geeky kid. And then they introduced me to a family friend at 12 who was working with Landsat at the time and got me excited about remote sensing. And I found this opportunity to sort of use technology and remote sensing to basically help people make better, faster, often more cost-effective decisions in their processes. I've done that through different things. I was research faculty at CU Boulder working with NOAA, 10 years with the NGA, a couple of different startups besides the one I'm at now, doing everything from visualization and analytics to now this. But so super interested in the LLM discussion just because we're launching a new spacecraft with compute on orbit, trying to figure out ways to get that data to people faster, help them make decisions more quickly and more effectively. And LLMs are definitely a big part of that discussion, although they're terrifying. So over to Abe.
Thanks, Ben. Good afternoon, Abe Usher. I'm the co-CEO of Black Cape. We're a company that specializes in rapid prototyping and building AI-enabled applications. My own journey in GEOINT has been over a period of decades. Like some of the other panelists, I previously served in the military in the 82nd Airborne and was really fascinated with the quality of 1 to 50,000 tactical maps that we got from the Defense Mapping Agency, a predecessor of NGA. Following the Army, I went on to be an early engineer at Google. I worked on Google Maps before it was an Android or iPhone app, and have a lifelong love of geospatial data. After leaving Google, I've been involved in a number of tech startups working on geospatial data. Really excited to talk with you today about LLMs. Back to you, Chitra.
Thank you, guys, and thanks for keeping it brief. I really love it. Okay, so I'm going to start off with Manil and Martise. So both of you guys have demonstrated experience deploying large language models and foundation models in the government and in industry. Could you give us a little bit of insight into what were the challenges you faced, what worked, what didn't work, how you guys are evolving your capabilities with large language models going forward?
Yeah. I'd say probably one of our first big challenges, because we're trying to serve commercial users, was really around latency. The time for an LLM to produce an answer to someone's question was like on the order of 5 seconds. People are used to sub 1 second answers a lot of the time. So we had to do a lot of work for being able to deploy smaller, more compressed models that were virtualized. And then we also had to reduce the latency overall in the cloud stack to make sure it wasn't going through too many applications or things like that, which was all creating a rippling effect of latency there. Another big thing was really around just how well it produced the answer against the type of question that you were asking. So a lot of you are familiar with like hallucinations and that kind of stuff. We had to do quite a bit of work and still do work to kind of understand how to tune the original LLM and then also like how do you refine the probability space that it uses to create some kind of communication projected out to the user. And scoping that probability space has been a really big effort on our part.
Yeah, from NASA's side, especially from the director that I'm involved in, Science Mission Directorate, we are looking into LLM and the foundation model in looking at the full spectrum of the science research lifecycle. By that, what I mean is before the data even gets to the users, there is a lot of curation, the stewardship that needs to happen so that it's science quality. That's right. For that purpose, we call it the downstream side of the things, upstream side of the things. That's where we are using LLMs. And on the upstream, the downstream side of the things, that's where we're using the science foundation model. So from the LLM side of the things, we started with the off-the-shelf large language models. And it was quickly evident that it was not doing well when you're going down to the domain-specific needs. And that's where we started working in our own domain-specific large language model. And that was a major effort in terms of computational needs. But more than computational need, it was the putting together a curated set of training data to pre-train the model, and then evaluate that model. That was a major effort because, as we know, every other week there is a new model, right? So how do you adapt to that? So you need to have a curated set of evaluation set so that you have a new model next week, you can properly evaluate that. On the downstream side of the things, that was a major effort because we're taking a science data, geospatial data, which has a lot of complexity, and you can't potentially take every single pixel to train your model, right? So there's a lot of effort in terms of data related as well, in terms of how do you do stratified sampling. Computational is always an issue. And that's where we were partnering with the commercial industry. We have ways to engage with the commercial sector for mutually beneficial aspects. And IBM Research was one of our partners. They helped us get us a large amount of computational resources and the foundational AI expertise that is needed. It's not like taking a library and building a model. It's a large-scale foundation model. It requires a completely new paradigm. And once that was successful, we were replicating that playbook. By the way, we're doing everything in the open because NASA science is all open science. Now we're partnering with other agencies like DOEs for their computational needs for mutually beneficial applications as well.
Thank you. And quick run rules for the panelists. Please interject if you have a strong opinion about what anybody else is saying. We'd love to get your thoughts. So with that, actually, I really love how you were describing this as we're building a new paradigm shift. It's not just the LLM. It's all these other things that kind of go into the foundation model that allows us to do GEOINT. I'm going to ask Abe, you've done a lot of technology integration and development over the years. How do you think about how these tools kind of interface and interoperate with our existing GEOINT tools? And how do we kind of extend this so that we're really kind of improving and building on tradecraft?
Okay, great. Well, Black Cape does a lot of rapid prototyping, and so we're interested, obviously both in the theory of what LLMs can do and also what they're ready for today. And before I get into how I see integration being realistic, just a quick story about my own personal experience. I've got 2 teenagers, and my introduction to LLMs was in January 2023. They're like, "Dad, you've got to check this thing out, ChatGPT. It's going to change your life." So I sat down with them at the computer, and they did a query. They know that one of my personal heroes is a lady named Admiral Grace Hopper, who was an early innovator in computer science and programming languages. So I proceeded to have a chat conversation with ChatGPT about Grace Hopper, and it was really like an amazing interactive experience. I felt kind of like I was having a discussion with Wikipedia. I was like, this is amazing. This changes everything. And then my younger son was like, "Dad, check this out. In addition to like basic knowledge, you can do these other things." And he put in a prompt with ChatGPT that was something like, write the instructions for removing a peanut butter jelly sandwich from a VCR in the style of the King James Bible. And it proceeded to make some plausible instructions that sounded somewhat correct, if humorous. And then I thought, this is completely terrible. This is a disaster. This is the worst thing ever. So, LLMs, I think they have some appropriate uses, and then they have some other uses where they're not really appropriate. Given that, I think in the year 2024, we don't have AGI and superintelligence yet. So a safe place where I think we can integrate these models is what I would call with a librarian model. We should not expect an LLM to be omniscient and know everything about GEOINT, but it could be informed about other geospatial tools that are not LLMs, and then prompted to go get information from those external tools. Kind of like the superhero Batman. He didn't actually have any superpowers, he just had a utility belt with tools that he used to overcome certain challenges. So I think the model of LLMs in 2024 should be a librarian helping us find external systems. And that requires NGA, the DoD, the IC to have application programmer interfaces, kind of modular open system architectures where systems have defined interfaces that LLMs can tap into. So that's sort of a precursor to being able to integrate with LLMs is we need integration hooks. The opposite of that model that I think maybe GEOINT 2035 or something we'll be ready for is actually having a super intelligent model that knows everything. Some of you may know the TV show The Good Place, where there's a character named Janet who knows everything. And you can say like, Janet, and give her a geospatial query, and she'll give you the exact answer. I don't think we have Janet-like technology in 2024. I think really we just have kind of entertaining librarians in the present. So thanks, Chitra.
No, I love that. I think in my previous startup, we used the Janet model too, and Janet's great because she knows a lot about you and what you're trying to do and knows where everything is. So I think in that sense, the librarian model sounds extremely fitting. So I'm going to take that and say, if I pivot off of that and say, like, let's pretend like these things can grow and we can build that librarian model, then it seems like the LLM needs to know something about what I'm trying to accomplish. So I'm going to say, maybe, Ben, you've got a lot of experience both in government and in industry. Same thing with you, Melanie. You've got both sides of the coin. How do we think about steering ourselves to the right use cases so that the librarian is helping us do the things we wanted to do and not the other things? And how do we think about those use case issues across the board?
Yeah, so one of the things I talk about a lot in my current position is, personally, I think our tasking and collection process for Earth observation is broken. The whole idea that I know where the thing is going to be at some time far enough ahead to like task the satellite to go get it is pretty silly when you think about it, and is probably why most intelligence reports I've seen start with NSTR when they relate to imagery. So, what if you could say, I am a warfighter out in the field, I've been asked to take the hill. What is on the other side of the hill? Are there any enemy combatants? What facilities do they have available to them? And the satellite would just go figure that out, and maybe even down to using multiple phenomenologies to do that. Be amazing. The chances, I think, of us really getting that to work right now, pretty slim. And so, the ways that could potentially go wrong if we allowed that out for somebody to use that, pretty terrifying. And what if it didn't have access to the key piece of data in its training that you needed to make that decision you were trying to make? And then I'm super interested in what you guys are seeing with this at Dante and stuff, but if this thing, all the models I've built did best when they learned from themselves over time. But what happens if an LLM starts learning from a bunch of secure users in a skiff that it's using their interactions to make itself better, and that starts creating data spills that we never even saw coming? So I think there's, some interesting stuff there when you start getting into more of the national security or even like disaster response space. Just where that could fall apart.
Yeah, and I think from our perspective too, as we've been developing models, we've been looking at more of an open architecture type of view, because we're very concerned about that also. If you're training up these models, or you're building in, even tradecraft on how you would go after taking the hill, you don't necessarily want that to bleed over. So, we think very much more around, how do you containerize these type of things? How do you set it up so that when it is learning from inside the organization, you can also have guardrails there. But also, how do we protect the users from getting into that false sense of security, if you will, where you want to trust things that give you the answer, right? Because you have other more important things to do. But at the same time, there's risk in that, in just kind of blindly accepting something. And so how do you build this right human augmentation type of approach where you're being informed, right, with context and the cross-modal information, but simultaneously you're still thinking and applying your own knowledge and tradecraft. So that's the balance that I think we have to kind of protect as a community, in my opinion.
So thank you, gentlemen, for that wonderful preamble for me, because that is precisely what we are working on right now. And the questions you posed, Ben, on what's on the other side of that hill, et cetera. So there's the librarian model that you talked about, Abe, and then there's that evolution of the recommendation engine and knowing the sensors and their ephemerals and all those sorts of things. And so those are the types of things that we are now working on because of that intimate knowledge about every single pixel on the Earth and how it's changed over the since 2017. And so we are now getting to a point where we can say, okay, this area here is changed, and this is exactly the type of change that's happened. Do you want to go task something? Oh, and for this type of change, you might want to use this sensor. And then the next phase is orchestrating those librarians. Because I think as you talk to your integration point, we need to be able to use the other geospatial tools we have available because they still have a specific purpose that we still need. And so I think you were talking about these extremely, extremely large language models, and then you were talking about these on-the-edge models that are more responsive. There's going to be some balance between those two to fulfill both the latency and the needs that people have, and they're going to need those LLMs on the edge. So a lot of the work that gets me excited as I watch our evolution is now we are able to ask it these questions, and in the future, I want someone either on their phone, like they use GPS services for marketing, to just be able to say, tell me what's over that hill, and have it delivered to their iWatch so that they don't have to ask anymore or task 55,000 people. And then for the geospatial analyst, they should never have to do their work alone again. They should have that assistant that is giving them those recommendations, showing them what's happening over their area of responsibility, because the assistant knows both what they're doing, what they care about from your librarian thing, and now it's making recommendations.
Yeah, I think from our perspective, we've seen LLM being used. We've seen the evolution of LLM in maybe 3 different areas: planning, right? Reasoning, and then interacting, right? From planning and reasoning perspective, we've been using that internally. Interacting with the external, we have to be really careful being part of the government, not giving false information, hallucination, right? In terms of planning and reasoning, it has made the human repetitive task really efficient. We actually have numbers in terms of how much efficient the humans are getting in terms of repetitive tasks. It's not automating, it's augmenting their tasks so that they can do much higher creative things, right? In terms of reasoning, one thing we've found is it's not very good at spatial reasoning or mathematics, right? LLMs are not good at that. So you still need a human to be fully integrated in that part of the, it's like left brain and right brain thing. In terms of interact, I think one of the reasons ChatGPT was very successful because it's not correct 100% of the time, but it's very simple to use, right? And that's where we're trying to focus, how can we enable large-scale data analysis with petabytes of data that we have, and have a natural or human language-based interface to those petabytes of data. And that's where our focus is.
I mean, that also kind of sparks another, part of the discussion, which is, they're large language models for a reason, right? They're not large mathematics models, and they do very well at translating between different things. So if you're trying to translate from one programming language to another, or one dialect to another, or having it right in a particular prose, using it for what it's good for, I think, is an important element. And to your point, we've already built up an industry many years worth, decades and decades worth of technology that are very good at solving some of the problems that you're talking about. And so in my mind, it's like, how do we leverage these models to do the translation down to, okay, what are the actions that should be taken? But then let's use the battle-tested methods, in industry that you all have been developing over the years, and leverage that as part of the next steps, and as a part of your overall plan. And to your efficiency point, how does the human ask the questions of that and then get served up? All right, these are the techniques that are battle-tested. Pick which one works best for you, kind of thing.
No, I think that's great, and I think a lot of what we're talking about here relies on historical data and how we're using historical data to help us derive these predictions, right? Because these are predictive models. So maybe a question to all of you guys is, where are gaps related to the data, and what do we have to do to close those gaps? Because in this case, what we've seen with LLMs is we have no context of time, right? So what decisions we've made or analysis we've made over looking at some region of the world or some geopolitical concern 20 years ago, we might interpret differently today, and we have no way for the LLM to derive any contextual knowledge around that activity over that region, over that piece of time, and how do I look at that analysis as a subjective analysis that was over a period of time, and how do I utilize that effectively to make a future prediction without just relying on the way we looked at the world back then, right? And I don't know if any of you guys have any thoughts on that. Abe, you look like you were leaning forward.
Well, there's a lot of directions we can go, just related to limitations and different scenarios of use. For the engineers in the audience that want to build something to help us use the technology, there's a famous paper in 2020 that Facebook published, now Meta, called Retrieval, Augmented Generation, or RAG for short, which talks about ways to extend LLMs. Instead of trying to retrain them every time there's new information, creating external semantic search services that LLMs for a given question can go externally and hit an external source. So how is this relevant? When I was at Google, like a very simple example of early retrieval augmented generation, so when people would do a search for pizza on google.com, and Google would interpret their IP address as an approximate location of where they were, and then use the spatial database of the local Papa John's, and then present to the user search results that were spatially relevant to them. So it was augmenting what they searched for with their location, actually calling out to an external database. And I think this idea of using LLMs incrementally, Melanie was talking about they're ready for some things right now, but there's a bunch of things within arm's reach. We can accelerate the use of LLMs by creating retrieval augmented generation systems that can tap into very easily without having confabulation and hallucination, but actual databases that are trusted within the DoD and IC. So I think, I don't know if this is related to the question, but I wanted to get out there and talk about RAG. Anyway, Martise, you're about to say?
Yeah, I was just going to say, the other thing that we, like as a community, I think need to be cautious of about RAG is the math is coming out and showing that, that's great for kind of scoping the space down to the domain-specific area. But then you got to partner with, people like what Manila's doing to build those foundational models to like drive out the hallucination part. And it's the conjunction of those two things together, I think, that are going to really help. If we tackle it from only one side, at least from my perspective, I think that we're gonna push the complexity elsewhere. But then we might have a really hard time converging on a solution that we need. So just kind of keeping both models in mind, I think, are important, or both sides, right, in terms of where that comes in.
Yeah, I think there's going to be some interesting challenges ahead that we can all figure out. And I'm going to flip over to a couple of these audience questions as they've been coming in. One of the things that everyone's looking at is like, is there an overall, consideration or concern if we quickly become over-reliant, right? And I think to your point on the trust issue, right? It's more about, is there something we have to do or design in the way we're implementing to make sure we're cognizant of where it's good and where it's not good and what we have to do extra, kind of mapping up, I think, the spatial systems and the mathematical systems that work well with our GEOINT data in conjunction with the LLMs, but to where, we're not overly reliant on it to be like the all-knowing system. And so I don't know if any of you guys want to take that one.
I'll start, and then I'll hand it back. So one of the cognitive biases that humans have is that we trust machines more than we trust other people. So I don't know if when Abe chose in King Charles versus Snoop Dogg, but if Snoop Dogg had told you about what to do with the VCR and the PB&J,
of course,
would you have trusted it a little less?
Probably.
Or Snoop Dogg through an LLM now is more trustworthy.
Right.
So there is a lot of bias that humans are going to have. They're more likely to trust the computer on the other side than you briefing them. So that's a very big concern, and then I'll throw it out to the rest.
Go ahead, Manil.
I was just going to interject in terms of science. That's where I come from. Scientists are never going to rely fully on automated systems, right? This notion of creativity comes from human. That cannot be replaced, in my opinion, no matter how much data you train these systems with. So you can always make their life very efficient, right? You can even have maybe one day robots do the actual experiments. But the idea of coming up with new hypotheses and figuring out a plan to do your research, I don't think that can ever be relied upon completely.
True, but we do have to consider that, especially like in the community and who we work with, that there are tiers, right, of roles that we're working with, and a lot of us have support functions for other decision makers, and that information is rolling up, and the ease of use of this technology is making it more and more plausible to get closer and closer to the individual decision makers, which some may have scientific backgrounds, some may not. And I think as a community, even though some of us will probably never trust it, right, from an engineering scientific perspective, we just need to be cognizant. I think that how it shapes up and how it showcases to the others that we're supporting is important.
I want to come back to the geo piece a little for a second. So, okay, we probably know how to organize all the data to train in these large language models, but I still live in a world where when it comes to geodata, trying to get it all assembled and properly put together is a super heavy task, right? I've got to normalize the fields in the databases from different countries, and I don't have enough imagery of this, that, or the other thing, or it's in different projections. And we're going to start asking this thing like, hey, go do something for me, right? Go tell me if North Korea is prepping to launch a missile from this launch pad. And how is it going to do all of that prep, right? Like, that prep's going to have to be done for it, and that seems like a pretty overwhelming task to get into. Like, I don't know, the geo part of that scares me when you get into trusting it to do it. I really like what Melanie said about letting it be a recommender as opposed to actually telling me something that's going to help me make a decision. I mean, even down to right, I know if I ask, what direction is the fire moving and how fast based on satellite data, it's probably going to be out of date by hours with our current collection capabilities. But somebody asks the model, what's the fire doing? It tells them, but they don't realize it's 6 hours old and the fire's already completely shifted in another direction. The geo part.
I'd like to come back to this issue of cognitive bias and trust. One of my favorite secular philosophers is a guy named Tracy Morrow. Some of you guys may know him. He got interviewed around 2010 about a big controversy around East Coast hip hop versus West Coast hip hop, which one was legit and which one was not. And they asked him, how can you tell the difference between a legitimate hip hop artist and someone who just gets on stage and rhymes? And he had a profound answer, which was, game knows game, baby. And by that, he meant if you have domain-specific expertise in an area, you're capable of recognizing it. So in 2024, I think human tacit knowledge, in particular GEOINT subject matter expertise, is going to be critical in the way we use these systems and understand their limitations. They do have some major limitations today. I wouldn't recommend anyone trying classified data on an unclassified system, but as a quick example, if you go to po.com, you can test out more than 50 different types of LLMs and see kind of what are the logical limitations of this technology today, right now, for free.
So I told Chitra I was going to steal it one more time. Back to where Ben said we're in geospatial. And so one of the beautiful things that we can do that finding the sources of the data for the LLMs on the natural language processing side is a little harder, is we can both trust but show. So see and show. Instead of show and tell, we can validate with those images. So for instance, not talking to the latency, but he can say, what made you come up with that recommendation? And now I can show you what made me come up with that recommendation. And as we start training these models across the right data sets for the geospatial, we can also cross-correlate between the data sets to get to more valid data and actively use that to improve the LLMs as we start getting these recommendations that the user agrees to. So I think we have a unique opportunity in the geospatial world that they can show and tell. So I can see the thing that made it tell me that, and I can also validate that it's at that lat long in my different tool sets.
No, that's awesome. And I'll just say anecdotally, in the early days, I did not trust my Google Maps, but I still used it. And then I would try to compete against it and see well, let's see if I'm going to go down the direction I know how to go down. And let's see who's right. And eventually you get to where you're like, hey, they're most often right. I'm going to listen to my Google Maps. Not always, but most often. So I'll deal with it. And I think we're probably on a similar curve of we don't have to trust it. We can trust it. We understand there's a lot of things that's wrong with it. But I think as long as we're architecting to give choice, right, and visibility and transparency, I think there's a better outcome. Now, with that said, there's a lot of folks asking about how we're dealing with these issues around, risk and model drift and model degradation. I know, Manil, you were talking about things you guys are doing to deal with how rapidly models are evolving and making sure that your algorithms that you're building are still in sync and follow some scientific rigor. How are you guys dealing with this, and how do we make sure we can still trust the thing we're building?
Yeah, so there's this parallel notion to models called data-centric AI approach. And that's basically what we're following. What that means is looking across data throughout the entire AI lifecycle. And mostly once you've deployed it, you have this set of evaluation criteria with new data coming in, whether it still meets the threshold of your accuracy or your scientific evaluation criteria. And for that, we actually invested a lot of time and effort from each of our science domain who work with geospatial data to put together a very robust set of evaluation set. This could be question answer for natural language processing, right? That the model is able to answer. This could be keywords, right? When you look at data sets or some articles, does it extract the information correctly? This could be a number of different things that are part of this evaluation suite that is also openly available, by the way, that we rigorously test against. And if it falls under the threshold, then we have to investigate, right, whether this model is relevant for our scientific purposes or not. So underlying principle is basically following the data-centric AI approaches, like keeping the model constant and changing looking at the data overall over the entire life cycle.
Yeah, I mean, on our front, we've had to build the instrumentation for it, right? So it's on the left-hand side for developing our models and creating the core models, creating the right kind of measurements. So we do that in our test environment and create, a bank of, different types of questions, because we use models for different things. It's not just geospatial. So we do that there, and then also we have other measurements that we put into production that we monitor real time, so that if things are, if our error rates start going up, we can be alerted quickly, go back and try to see what's going on. Do we need to tune the models in that way? It's still kind of exploratory field also because it's semantic. So there's this qualitative aspect to it that can be difficult to quantify. And so there's still a lot of research and whatnot that we're trying to do. So our major focus is really just like, how do you build your environment so that as these new techniques or as these different types of measurements come out, we can rapidly deploy that instrumentation and see how it's doing.
Yeah, I think that's an interesting observation too, because there's one thing related to model drift and the model mechanics that we can think about, but you might find that there's an outcome difference even in terms of how we utilize something over time, just because it is so language-based and language evolves so rapidly. So there's a lot of complexity there. One of the things that I'd like to understand is how you guys think about, I guess, overall governance, both in terms of your internal applications and kind of following the CDAO guidelines. Like, how are you all taking an aspect on managing to the new standards around governance?
So on our side, we're going through pretty rigorous documentation and trying to understand from the system audit trail perspective, what are the models doing, what's our training input criteria, how are things changing over time, who's changing it, that kind of stuff. And really, we're just kind of starting with the basics of our audit trails and then measuring against that.
No, that's great. Okay, I'm going to throw a question out to all of you guys if you have any advice. I know if you're a venture-backed startup, it's easy to kind of work through some of these pieces and get access to the compute necessary and the models that you need to develop. If you're a large government organization, you obviously have bigger, deeper pockets than most companies. Sometimes. But if you're a small services company, like many of those who are supporting the GEOINT community, how do people kind of think through strategies to effectively get access to compute and access to the capabilities they need infrastructure-wise to start playing around and utilizing LLMs?
I mean, there are a number of programs that all the large cloud providers have. OpenAI has a program, Microsoft has a program, Amazon has a program in terms of giving compute to startups. So I would definitely look into that. OpenAI has a great program that has both the compute environment and the models.
I think that has been the priority of this administration. NSF is leading the something called National AI Research Resource. They're running the pilot program right now, and I think most of the government agencies who do have computational resources are contributing to it. And obviously, we cannot use it for commercial purposes, but if you're doing some research and that can lead into commercial later, you can obviously use it, and it's also supported by industry as well. So I think tomorrow is when they will open for public. So if you have any projects that requires a lot of GPUs, that's the place to go.
That's awesome. Okay, we've got less than 2 minutes left, so I've got a really good question here from the audience that I'm going to just read verbatim, and we start with Abe and go down the line. How are each of you personally incorporating LLMs into your daily workflows to enhance your job performance and productivity?
Good question.
Let me pass to Ben and then come back to me.
Oh, wow, thanks. The first thing I did when ChatGPT came out was actually go to it and say, hey, ChatGPT, is it safe for me to put company proprietary information into you? And it said, no, don't do that. And I actually had to show that to all my employees because I found out some of them were like putting stuff in there. I was like, what are you possibly thinking? So, I mean, for me, until we're pulling it in, right, with stuff like what these guys are doing, where it's going to run on my systems and be protected, and I know how it works, till we have something like, SOC and CMMC aren't perfect, but something like that, I suspect, is going to come out for like certifying that you are building these models. Like, you guys are all figuring it out for yourselves, but some standards got to be coming, right, for assuring that. So yeah, for me at work right now, the only thing
can
it
be
does is
personal,
give me
too.
things to think
Personal
about.
too, Ben.
Yeah, I mean, we just deploy an internal one and use our own for that. But just like to answer quickly, I mean, we'll use it quickly for debugging stack traces, translating to different code. Sometimes we'll even use it to just kind of create a scaffolding of a concept and then build on top of that. You know.
I have about 10, 15 prompts that I use all the time. Obviously, working in science, everything's open, so I don't have to hide anything. But things like giving a set of bullets and asking it to write a coherent paragraph for reporting, I do that up very often. Summarizing research papers, I do that all the time because you have to stay abreast with all the research going on in the field. What else? There are a number of other things.
All right, I'm paranoid, so I don't put anything into it except when I'm in the UI for impact. If I'm going to do anything, I sneak onto my son's computer, but I don't want ChatGPT training on my background, so I don't put anything in it.
Well, I'll come back to 8, but I'd say my last one is sometimes my mom sends me long, wordy texts, and I ask her to tell me how to respond. It works really well for that, so it's a really good use case.
You've got the South Park romance.
Exactly. No, thank you all for this. This was a great conversation, and I'm sure anyone in the audience can hit up this group of folks and figure out how to work with them. Thank you.
Thank you.